Here we are asked to find either the maximum or minimum for an application type problem. The first thing to do is make sure that you understand the problem well and the notation. This problem says that the temperature of a patient during an illness is given by capital T of little t equals this function. And then notice that it gives you an interval for your t values. It says capital T is the temperature in degrees Fahrenheit and little t is the time in days after the onset of the illness. So on here, make sure that you make a note that little t is your days, and then capital T, which is the y value for the entire expression, is the actual temperature of the patient in Fahrenheit. It says graph the function using a graphing calculator and use the maximum feature to find the time in which the patient's temperature is the highest. So there's the maximum part. And then it also asks what is the highest temperature. So the first thing we want to do on this one is figure out how we want to enter the function in our calculator. The calculator in the y equals menu only accepts a variable of x. So we want to rewrite our function so y1 would equal negative 0.2, and instead of saying t squared, we would want to write x squared. And then plus 1.6x, and then plus 98.6. Notice that the 98.6 is the y-intercept of the function, and also notice that from what we know about science, 98.6 is normal body temperature. On here, we are given our domain of the function. In other words, them telling us that our number of days range from 0 to 8 is telling us the domain for this particular function. So we would know that when we're trying to set a window for this function, that our x values, or our t values, little t, should range from 0 to 8. Okay, so that's very helpful in us deciding what we need to plug in for our window. Now, the actual y value, which would be the temperature, would be the range for the function. So in us trying to figure out how to give an appropriate graph, we need to consider the range. Well, 98.6 we know to be the y-intercept, and so we need to make sure that our y values are large enough that that y-intercept would be included. The other thing is just thinking about it scientifically. We know that normal body temperature shouldn't get much below the 98.6. And so on here, what we might be able to do is make the low y value 97 degrees. And then also we know that we don't need to get our temperature very high, and so we might want to set a high temperature of 105. That's extremely high, and we know if we get too much higher, then that wouldn't be a good thing. So this, as far as setting the window, having some information, scientifically about what we know about the human body helps us determine what those high and low y values might need to be. And no student is going to do that exactly the same, but it should be kind of in that ballpark. From here, let's enter our function and then we will graph it. If you have a function in there, clear it out. So in here we'd have negative 0.2x raised to the second. I have to arrow over, plus 1.6x plus 98.6. Go to the window, and we will use the window we have set here. So the y minimum needs to be 0. The y maximum needs to be 8. We would leave the x scale at 1. And then the y minimum needs to be 97. The y maximum we've set at 105. Leave everything else the way it is, and then just press graph. So what we'll do is we will sketch the graph that our calculator has yielded. And you don't have to be exact about it, but just give the basic idea. We're going to come and label our x and y axes. The x-axis originally in the problem was actually t, which was days. And then the y-axis was originally capital T, which was the temperature in Fahrenheit. So we'll label both of those. I will also label our scales. So we went from 0 to 8 on the t-axis, and then here technically what I should do is put a little jag showing that I did not start at 0, but I started instead at 97, and then I went up to 105. We see that this ended up being a good window. It shows our graph well. And then it said, the question I believe stated, what was the time in which the temperature was the highest? So they want to know what's the number of days when the patient's temperature reached that highest peak. And they also want to know the highest temperature. And so if we can find the order pair for the relative maximum, then we have both of those pieces of information. So let's go on our calculator and find the relative maximum. So we would do second trace. We want to choose option 4 for maximum. On here, be careful, every now and then your calculator may actually take you to the relative maximum or relative minimum. I would go ahead if I were you and I would perform the actual work on the calculator. So when it's asking for a left bound, let's arrow to the left. We see up here at the top there's that kind of flat part. Make sure that you fall off of that flat part. So we're going to arrow to the left, fall off a little bit, press enter, arrow to the right, go over that flat part, and then press enter when you fall off the other side. And then when it asks for a guess, just press enter again. Okay, and it looks like here the maximum value is 3.999, and then y equals 1.018 would be the maximum. The x value I would actually round in this particular situation. Some of you, like I mentioned in a prior video, may have gotten actually 4 or 4.001. That x value is sometimes not as accurate for each individual person, so we will a lot of times round that. So it's going to be 4 and then 101.8. And so I believe we have enough information to answer our question. So we would say the time at which we reach the highest temperature is day 4. So that answers the first part. The high temperature, or the highest temperature, was 101.8 degrees Fahrenheit. And so we've got both pieces of that question answered.